All right, in the second part of section 8.2, we're going to look at classical curves of polar equations. First part, we looked at general curves, circle, line, horizontal, and vertical lines. The second part, we're going to look at classical curves, and we're going to do each of these videos separate. So first video is going to be circle, then a cardioid, limacon, rose, lemniscate, and spiral of Archimedes. So if you look in your packet, you've got 6 graphs, really 3 pages, and they're printed front and back. So I've already wrote down the name and the equation beside here. So this first video, we're only going to look at a circle. So if you need to go back and look at one of these, you won't have to fast forward to try to find it. So the first video, all we're going to focus on is how to graph a circle. Before we looked at a circle with my my center being at the origin. Now we're going to look at it maybe not being at the origin. All right, so first thing we're going to do is we're going to make a table. To make a table, we're going to use our calculator. So first thing you need on your calculator is go to mode and make sure your calculator is in degree mode, which it should already be. Next thing we have to do now is turn this thing into polar mode. So down here where it says FUNC, that's function. And if you look over here to POL, that stands for polar. So we need to change this into polar. So we're going to highlight it, hit enter to change this into polar mode. Next thing we're going to do is type our equation. Now, if it was in function mode, it'd say y equals, typically mx plus b. Now, when we go to hit y equals up there at the top, now you notice it says r equals, which is what I need, r equals. So I'm going to type this right-hand side of my equation in, 6 sine. Now, the easiest way to get theta is this x button like we typically use. But remember, we turned this into polar. It was the third one, so xt, that theta is the third one. So when we hit that, theta is going to pop up. And I'm just going to close that parentheses right here. So now, next thing we need to do is we need to go to our table set to make sure everybody's table is set up the way that this one looks over here on the right-hand side. So second window is going to be my table set. And this is what I need for you to do for your table set. First thing, we want our table to start at 0. Yours may say something different than mine, but we can make everybody's the same by setting it to 0. Next thing, this little triangle right here just means how often you want your table to increase by, how much you want it to go up. So if you notice over here on my table, it's going up every 15 degrees. So we want this change in our table to be 15. Now my independent and my dependent both need to be in auto, no ask. If this is an ask, you're going to have to type these thetas in every single time, which would be too much of a pain. So here, let's just make sure both of these are in auto. So here, you're just going to click on both of them to make sure that you're there. Now, if your table's set up right, 0, 15, auto, next thing you're going to do is you're going to go to your table. So we're going to hit second graph to go to my table. And as you notice, it's starting at 0 and is incrementing by 15s as we get throughout. Now, to get to my problems over here, I'm just going to round these things to the nearest 10th. So first thing, I've got 0, and I'm just going to copy my chart. So we've got 0. Next one we got, this 5 is going to bump this 5 up, so that's about 1.6. Then we've got 3. I'm just going straight down right here. Then we've got 4.2. Then the next one we got is 5.2. Then we've got 5.8. And then we've got 6. So that's up to 90 degrees. Now I'm going to take my table and move where 90 degrees is no longer found. And I'm starting at 105 right here to make it easy. So this is 5.8. You notice things are the same right here. We've got 5.2. I'm rounding here, don't forget. I've got 4.2. I've got 3. I've got 1.6. And then I've got 0. And that's at 180. So my next one I'm going to start at is 195. So I'm going to scroll my table up to where I see 195 being the start of it. So here we back to negative 1.6. You still see symmetry right here. Negative 3. Negative 4.2. Negative 5.2. Negative 5.8. Negative 6. All right, so I got this last quadrant left. So I'm going to scroll up to where 285 is at the top. And I start right here with negative 5.8. So negative 5.8, negative 5.2, negative 4.2, negative 3, negative 1.6, and I'm back to 0. So that's just me using my chart and scrolling down to get these values over here on this right-hand side. All right, next thing I'm going to do is take these thetas and r's and graph these polar equations. Remember, we said this should make a circle right here, and you're going to notice some symmetry going throughout. So at 0 degrees, I'm going to go to 0. So that's just basically the point 0, 0, centered at the origin. 15 degrees. Here's 15 degrees. I'm going to go out to 1.6. Here you just have to estimate. So here's 1, here's 1.5, so just go a little bit further. At 30 degrees, we're going to go to 3. Here's 30, so stay on this line. You're going to go out 1, 2, 3 circles. At 45 degrees, I'm at 4.2. Here's 45, so let's go out 1, 2, 3, 4, and just a little more, 4.2. At 60 degrees, I'm at 5.2. So here's 60, and I'm going to go out 5.2. 1, 2, 3, 4, 5, and just a little more. And you can see it's starting to turn right here. At 75 degrees, which is right here, I'm going out to 5.8. So 1, 2, 3, 4, 5.8. That's really close to 6, but not quite there. And then at 90, I'm back to 6. So at 90, go out to 6 and put a dot. So this is going to be the right-hand side of that circle if you can see it curving already. All right, now we're at 105 degrees. Here's 105, and I'm going to go out to 5.8. So I'm going to go back to counting. 5.8, really close to 6. Remember, just like that one over there, it should match it. 120 degrees, I'm going out to 5.2. So here was 5, 5.2, just a little more. Remember, those two should match. They were both 5.2. All right, 135, I'm at 4.2. So just barely past 4. At 150, I'm back to 3. You can see it kind of start curving back in. At 165, I'm at 1.6. So here's 165. 1.6, remember, a little bit more than halfway. And then at 180, which is right here, I'm back to 0. All right, so that's the first half. All right, now let's look at the next part. At 195 degrees, here's 195 degrees, I'm at negative 1.6. So I can't go out and put a dot here. I have to flip it across. Well, if I flip across 195, see, I'm back at 15 degrees. And if I go out 1.6, that's the same point I already had graphed. At 210, here's 210. I can't go out to 3. I got to flip it. So straight across from 210 is 30, and I go out 3 units, and I already had it graphed. So if you keep going through all these, basically what's happening is just flipping across to get the same point that you already had graphed. So if I connect my dots right here, doesn't matter which way you start, this is going to make a circle. Now, we talked about circles already, but the circle we talked about was centered at the origin. This problem here is not centered at the origin. Now, a circle can come right here and be above, or a circle can come down here and be below. How's it going to be below? If this number right here just happens to be negative. The other thing we can have, you see how these are kind of floating on this y-axis right here? If I wanted to float on my x-axis right here, all I have to do is just change the trig function. Remember, sine went with y, so that's why this one's on the y-axis. But if I change this to cosine, then I'm going to land on my x-axis over here. So that's how we graph a circle.